afternoon, everyone. Welcome back to our webinar presented by Nehemiah STEM Research. My name is Mohazi Donald, and we'll be continuing with Solidity. Last week we looked at inheritance and calling parent contracts. Today we'll be looking at visibility. And visibility. Sorry, just give me 1 second. So we're going to be looking at mastering one of the most fundamental concepts in Solidity, which is visibility specifiers. And basically we're going to learn the difference between public, private, internal and external, which is crucial for writing secure, well-organized and gas-efficient smart contracts. We'll break down exactly who can call your functions and access your state variables, covering the 4 visibility types that I just mentioned for functions, and then the 3 for state variables, the critical security implications of each visibility level, and then all this will be covered in our code example, and then after finish typing it up, then we can look at a line-by-line breakdown or walkthrough. So thank you for tuning in. Don't forget to like this video, subscribe to the channel, leave a comment, share. So before we get into the coding, let's define a few things. First of all, what is the visibility concept? Visibility in Solidity specifiers, in Solidity, visibility specifiers explicitly define the scope from which a function can be called or a state variable can be accessed. This is a core security feature that prevents unauthorized access to contract, logic, and data. And the 4 key types of visibility, like I mentioned before, we have public, private, internal, and external. Now, public is the most permissive visibility for functions. So, public functions can be called from anywhere, inside the contract, inside derived contracts, by other contracts, and by external accounts for users. And for state variables, the compiler automatically creates a getter function, making the variable readable by anyone. And then for the private key type, this is the most restrictive visibility type of key or visibility type. Private functions and state variables are only accessible from within the contract where they are defined. and they are completely invisible and inaccessible to any other contract, including child contracts that inherit from it. So as we were looking at inheritance last week, so if the parent contract had a private function, yeah, inside it, the child contract wouldn't be able to access it, or it would be invisible to the child contract. Then we have the internal visibility. So the default visibility was state variables. So if you don't specify one, the internal functions and state variables can be accessed internally from within the defining contract and all contracts that inherit from it. So they are not accessible from outside the inheritance chain. And then we have the last one, which is external. So similar to public, but with a key restriction. External functions can only be called from outside the contract by other contracts and users. They cannot be called internally from, let's say, within the same contract, unless, let's say, when you're using, see if I can type it here. So unless it's like this, yeah. So this, yeah, is a gas optimization for certain cases. Yeah. So it will only be called internally if you use the syntax this. Then we can define what the state variable rule is regarding visibility. State variables can be public, private, or internal, but not external. So it only, for state variables, there are only 3 cases or types of visibility that it can have, which is again public, private, or internal, but not external. This is because external is designed for functions that are called via a message call, which doesn't make sense for a variable that is simply stored. Yeah. So we got all those defined, then we can start our example here to look at all 4 of those. So we'll look at inheritance again, using the inheritance to look at basically all this. So yeah, we're starting with the private here. just confirm because it's the same contract. Emma, help me tell those ladies to after that, then we can do the contract inheritance, the contract that's inheriting. So if I try to call it, you can see it's already saying declaration error and declared identifier because it's not visible, because in the parent contract it's a private function, and remember inherited contracts do not have access to private functions from the parent contract. So we would have a compilation issue if we try to compile this contract. So I'll just comment this out. An internal function, however, can be called inside child contracts. Okay, so this is it. Then we can now walk through the code. So we declare a contract called base, which is basically the parent of base contract, and it has a private function. So like we were saying, we're looking at visibility. So the word private here is the visibility specifier. So this means that the function can only be called from within this specific contract, which is the base. And the syntax pure basically is state mutability modifier. So the function does not read from or write to the blockchain. Then it returns a string in memory. So basically the function's base is going to return a string, and that return is private function called. So whenever we call this function, it will return that string, private function called. And then line 11, function test private function public pure returns. So it's a public function that acts as a wrapper or getter for the private function. Yeah, so this is because we've declared it public, it will automatically gets a getter call, and what we've told it to do is to return basically this, and it will be the same as this basically. Then line 17, function internal pure. Here the visibility specifier is internal, right? Yeah, well, line 17. So this function can be called from within the base and from any contract that inherits from the base. And the inheriting contract in our example here is child is base, so it can be called from within this base contract as well as the child contract. And this function basically is the same or similar to the private one, which is to return a string called internal function called. Yeah, and then line 21, of course. Function test internal function public pure virtual returns. This function can be called from anywhere. And the virtual keyword there allows the function to be overridden or customized by a function in a child contract, like we covered last week, looking at inheritance. And then line 28, function public pure returns. So public, this function can be called from anywhere inside the base, inside the children or child contracts, and by external callers. Like we said, this is the most common visibility for functions that need to be part of the contract's external interface. And then line 34, function external pure returns. The visibility specifier there is external. yeah, here. So this function can only be called from outside the contract, for example by a user or another contract. It cannot be called internally by other functions within this base contract without the special contract syntax, which I talked about earlier. If you remember, it's this dot and then the function name, which in this case is, so it would be like this external, so something like that. So without that special syntax, it can't be called internally. And in the comments, of course, I was trying to show you that, basically trying to explain that like if I uncommented this out, yeah, if I uncommented that out, I was basically trying to demonstrate the classic error, which is basically that an external function cannot be called directly from within the same contract. Yeah, so after uncommenting, you could see that the compiler threw this red error, which is that it cannot call the external function internally. So to call the external function internally, we must use the syntax this, then external function. So it creates an external message call, which will cost more gas. So I'll leave it out. Then line 46, we have some state variables there, line 46 to 48. So a state variable with the private visibility, that's line 46. So it can only be read or modified by functions inside the base contract. Important note, even private data is visible on the blockchain, so this only prevents other contracts from accessing it. So anyone can read the raw blockchain data. And then we have another one, which is a string internal private internal variable, which is my internal variable. So it's a state variable with internal visibility, so which is the default for variables. So it can be accessed by the base contract and any contract that inherits from it, like you see below here, the child contract. And then line 48, string public. Here it's a state variable with a public visibility. So this means it automatically generates a getter function named public variable. Anyone can call this function to read the value. Writing to the variable still requires a function within the contract. And then after that, line 56, we declare the new contract child that inherits from the base, which we've just been looking at, using the is keyword. Yeah. Then you have so if I just show you from here. So if I take out the comment line of slashes, here we're demonstrating that a child contract does not have access to the private members of its parent contract. The function, private function, is undeclared and invisible from the perspective of the child contract. Because remember, if its visibility is specified to private, like here, that means the inheritors can't see it or access it. It's only accessible within the base contract. So that's why the compiler throws that error. Hence the comment. And then line 64, function test internal function public pure override. The override keyword is required because this function is overriding the virtual function of the same name from the base contract. Then return internal function. So this is perfectly valid. A child contract is calling an internal function defined in the parent contract. And then line 69, function get internal variable. It's a new function to demonstrate accessing state variables. Then 70, return. Then so this is valid. The child contract can directly read the internal state variable, which is this internal var, inherited from the base. Yeah. So in summary, this code example is basically to demonstrate the practical application of all visibility specifiers. It uses a base contract to define the base contract here to define functions and variables with different visibilities, and then a child contract that inherits from it. The code shows what is accessible within the same contract, what is accessible from the child contract, and what is accessible from an external caller like a user, which we'll see after we compile and deploy. And then of course the common mistakes that will not compile, providing clear examples of what not to do. That's what I've showed you today. So let's compile this and then deploy, and then we'll see what we're able to access as the user. So deploy both the parent or base contract along with the child. So if we expand the child, we can see has access to the external, because remember the external visibility type can be accessed outside the contract, the base contract, by users or another contract. And then we have the, okay, let's just interact and then see. But this is what we have access to. So if we call the public function, it should be able to return, yeah, a string which is public function called call external function called in the public variable, right? Public variable, my public variable. So remember, this one is the auto-generated getter function. Because the state variable was declared public, it generates an automatic getter function. So let's test the internal items via the child. We have the test. Internal function code. So this proves that the child contract has access to the parent's internal function. So it called the parent's internal function basically, and then get internal variable. Okay, I typed this wrong, but yeah, it's variable. So yeah, that also proves that the child can access the parent's internal state variable. And then now let's try and test the private ones. So if we switch to the base, private function called, so that proves that the private function can only be called from within its own contract, which is basically via the public wrapper. The public wrapper being the function we put. Let's see here. This is the public wrapper, but remember, this is the private function. And then yeah, so we cannot call the private function directly on base, so it's not visible in the Remix UI because it's private. Yeah, that's it. Thank you for tuning in. That was it for visibility in Solidity. We've covered private, public, internal, and external visibility types in Solidity, and how they work with inheritance and how they are called. Have a blessed evening. We'll meet back at the same time tomorrow.